All right, so today we're going to do some review problems on limits and evaluating limits at points. And again, when you have limits, rational or polynomial or otherwise, we want to start with direct substitutions. When I look at the top limit here, I want to see if I plug 2 in to the denominator, is it a value we can live with? Well, 2 minus 2 is 0. So that is not a situation we can deal with, so we're going to have to use our limit laws to simplify this. So we have to do some factoring. All right. If we're going to factor this, I think you can see that this factors to this. And this allows us in our limit laws to do this and substitute now 2 in there. Well, that becomes 2 plus 3 when we substitute 2 in here. So the limit, this limit is equal to 5. And again, we just did the limit laws at that point. So, looking at this next example, I plug in 2, direct substitution doesn't work. So I factor, and this time it's x minus 3. Well, this is a case where nothing cancels. So guess what? This limit does not exist. And if I was to look at the hands, the left hand and the right hand, I might be able to determine if it's approaching positive infinity and negative infinity, but the limit itself in this case is not going to exist. Got 4 more. On this page we got 2, and I'm going to do these the same way. Again, I look here at the top limit, and I plug in negative 3 into the bottom of the rational function, and I'm going to get 18 minus 21 plus 3, that's 0. So again, I cannot just simply substitute it in, I cannot do direct substitution, but I can do some factoring. And immediately on top, we probably see this. And we realize if this is going to give us a value, t plus 3 is going to have to be one of the factors in the bottom. So I'm going to take a guess that it's a factor. 2t and t make 2t squared, 3 and 1, plus 1 and 3 makes 3, 1t and 6t makes 7t. So that is correct. And again, our limit laws allow us to cancel this. And now if I substitute negative 3, I get negative 6 over negative 6 plus 1, negative 5, for an answer of 6/5. Now, the bottom one has a form. We should recognize this form as the derivative. And I'm going to do that the second way on the next page. But right now, I'm literally going to, I can't put h to 0 in, I can't do direct substitution. If I square out my 4 plus h squared, I get that. And they cancel. And then h is here, so now I can cancel an h in every term, and I get 8 plus h. If I put in 0, 8 plus 0, this limit is 8. We really don't want to do it this way. When I look at the limit here, I'm going to do these 3 by recognizing all 3 of these are in the definition of derivative format. All right? And what I mean by that is when we look at the board right now, we should recognize all 3 of these have this format. F of a plus h minus f of a all over h. And we've learned that this is the derivative f prime of a. So when I look at the top function and I think to myself, this is simply a derivative, instead of doing the work here, I want to identify the function and the variable. And instead of 16 here, I have to say, well, it has to be something squared for it to be a. So how about 4 squared is 16? And I can immediately see that a is 4 by the 4 and the 4. And I see that the function f of x is simply x squared. All right, I want the derivative of x squared evaluated at 4. All right, so I want f prime of 4. This is not that hard. I take the derivative of 2x, plug in f prime of 4, 2 times 4, and the answer is 8. Like we would expect, it is the same. All right? Again, the next 2 are the same. If I go to 100% and move down the screen, The next two are exactly the same, all right? And if I go with this one next, we should see, again, that this is in a format that we should identify. And I can write this as 1 to the 4th and still have it be a value of 1. So A is 1. The function up here is f of x equals x to the 4th. I know this is a derivative based on its format, and I get f prime of x equals 4x cubed. Evaluate at 1, and I get that the value of this is 4. So the value of this limit is 4. Last one, same format. F of a plus h is right here. This is f of a, and this is h, and this is h. But it's just using a delta x. And actually, I got a little mistake here when I wrote it for it. I meant to have this be delta x here also. All right, so again, we should see that the value at a is a half. We're evaluating a half. Hopefully you caught that the function is x to the 100th power. All right, and again, evaluate the derivative, f prime of x, power rule, 100 x to the 99th power. And I'm not going to do this one out because f prime of a half is going to be 100 times the quantity 1/2 to the 99th power. And I would have an overflow error. Maybe it would be this way on the AP test. We should be able to see that the evaluation of that function is equal to 100 over 2 to the 99th power. Again, keep practicing using the limit laws. Quick review of calculating limits using the limit laws.